Hello friends, today we will solve out the problem associated with applied mechanics, and in the dynamics portion we will particularly deal with the kinetic section. Here we are asked to determine the resulting acceleration of the block when they are capped at 30 degree and 60 degree as shown in the figure. Here two rough inclined plane at 30 degree and 60 degree to the horizontal and are same height are placed back to back. The mass of the block A and block B are 12 kg and 24 kg respectively. Determine the resulting acceleration if the coefficient of dynamic friction is 0.6. Here we are given two blocks A and B having respective masses 12 kg and 24 kg that are placed in an inclined plane 30 degree and 60 degree respectively, and they are tied up with this string. So we are asked to determine the resulting acceleration that exists in this system. Now friends, we shall consider the certain assumption in this problem. Let us suppose that XA be the position of A with respect to this fixed pulley. Likewise, XB be the position of this block B. And let us suppose that the acceleration in block A be A and the acceleration in block B be AB. So these are the assumptions that we have considered. Now friends, what we can write is XA plus XB equals to a constant, isn't it? So that we can write, because this is a continuous rope, and we can write XA, the position of XA and XB equals to constant, isn't it? So friends, if we just derivative this, we can easily get VA plus VB equals to 0. So if we again derivative the velocity, then we can get acceleration of block A plus acceleration of block B equals to 0. So this is the relation we get. So we can write acceleration of block A equals to negative of acceleration of block B. Here the negative sign indicates that if the block A moves towards this reference point, then the block B moves away from this reference point. So while substituting the value, we will just substitute A equals to AB. So this negative sign just indicates the direction. So if A is moving towards this pulley system, then B shall be moving away from that. Now friends, we shall draw the free body diagram of block A and block B. So while considering the free body diagram of block A, we can see that the block A will be moving upward, moving towards the pulley, since the mass of block A is less than the mass of the block B, isn't it? So the tension here, in this case, tension will be acting upward from the away from this block A. Likewise, this angle is 30 degree, and if we resolve this, then along this direction the component shall come out to be mg cos theta. Likewise, mg sin theta will be acting leftward. Again, since the block is moving upward, the friction force shall be acting to the downward direction. So the net force shall be acting upward as shown in the figure. So this is the free body diagram of the block A. So from the given free body diagram, from the drawn free body diagram, what we can write is T minus ma g sin theta. So theta is 30 degree, isn't it? Minus F, friction force. So friction force is mu times the reaction, normal reaction. So mu is 0.6 here, and the normal reaction can be easily seen as mg cos theta. So it can be written as ma is the mass of the block A into g into cos theta. Theta is again 30 degrees, isn't it? So that value shall be equal to the net force, that is MA into acceleration of block A. So if we solve this, then the value of tension shall come out to be 12 is the mass of the block A. If we solve this, 4.91 plus 5.10 plus AA shall be the acceleration. So this shall be the equation 1 while applying the summation of forces equals to the net force. Similarly friends, we shall draw the free body diagram of block B. Here the block B is moving downward, so the net force will be acting like this, and the angle of inclination of this inclined plane being 60 degree, we can easily write the component of weight mg cos theta acting like this, and the normal reaction R is acting like this, and the tension is acting away from this block. Likewise, since this block is moving downward, so the friction force will be acting just in the opposite direction. Okay, now let us write the, so what we can write is, since the block is moving downward, we can write the mass of block B into G into sine 60 degree minus tension minus the friction force. The friction force is given by mu into R. So mu is 0.6, that is coefficient of friction, and R is the normal reaction. So R in normal reaction shall be given by mBg cos theta. So that can be written as mass of block B into G into cos theta. Cos theta, theta is again 60 degree, equals to, so what we can write is mass of block B into acceleration of block B. So while solving this, the value of tension in this case shall come out to be 24 times, so we have to put MB, mass of block B, as 24. So it will solve, when we have solving this, we can easily get 24 8.50 times 2.94 minus AB. So this is the expression 2. So we have obtained one expression from block A and the second expression from block B. So the tension in this case is equal, since this is only one rope. So we can equate equation 1 and equation 2, and after equating equation 1 and equation 2, so after equating equation 1 and equation 2, we can get 10.01 plus AA equals to 11.12 minus 2AB. Okay, since we have already determined one thing, that what we have determined is AA equals to AB. We have determined that, and we need to neglect the sign of, and if we put A equals to AB, then what we can obtain is 3AB equals to 1.11. So the acceleration of block B will come out to be 0.36 7 meter per second square. So this is the resulting oscillation of block B. Likewise, the oscillation of block A is again 0.37 meter per second square, and the negative sign just indicate that A is moving upward towards the pulley while B is moving away from the pulley. So AA is again 0.37. This is the way we can solve out the problem.